Hey guys, I'm going to go through some pressure problems for you. I want you to make sure that you have this printout first, or you're looking at it so that we can go over it. I'm going to do a couple problems, and then you are going to do the rest for homework right now. Okay, so I'm going to do number one. Remember, the pressure formulas we're going to use are pressure equals force over area, okay? And then we're going to use P1 equals P2, or it's also F1 over A1 equals F2 over A2. These are basically the same formulas. This formula right here, this one is this one, but this is if you're using two pistons, okay? Remember, they're equal to each other. Okay, so let's do number one. It says a book is sitting on a desk. The area of contact between the book and the desk is 0.06 meters squared. If the book's weight is 30 newtons, what is the pressure the book exerts on the desk? Okay, so we're looking for pressure. So we're going to do pressure equals force over area. Okay, sorry, my help. Okay. So my force is 30 newtons. Okay, my area is 0.06 meters squared. Remember, newtons is force, area is length times width, so it would be meters squared. When you put that in a calculator, which I lost my calculator, so I'm going to use my phone, 30 divided by 0.06 is 500. 500 what? Pascals. Okay, this one is pascals. All right, so if you're using this formula right here, you're solving for Pascal. Okay, so remember, if you're looking at some of these other ones, like I'm looking here at number 4, it says kilopascal, and you're going to use the pressure formula. So you've got to change that from kilopascal into pascals first. Okay. So that's something to look for. All right, the other problem you're going to have is pistons with two pistons. So let me go over those. Number 6, okay? Now this one right here, number 5, it's one piston. So you're just going to use the actual pressure formula. But this one here is 2 cylinders contain pistons that are connected by fluid in a hydraulic system. A force of 1,300 newtons is exerted on one piston with an area of 0.05 meters squared. What is the force exerted on the other piston, which has an area of 0.08 meters squared? Okay, all you have to make sure is that your area 1 is the same as the same piston is 1 and the same piston is 2, basically. Okay. So I'm just going to, whichever one is named first, I'm going to make that my piston 1, and whichever is named second is my piston 2. So force on this one would be my piston 1, and this would be my piston 1. So this would be area 1, and this would be force 1. Okay, what is the force? So we're looking for F2, on the other piston that has an area of, so this is my A2. Okay, so I'm going to use the formula F1 over A1 equals F2 over A2. Okay, so my F1 is 1,300 newtons. My A1 is 0.05 meters squared, 0.05 meters squared, equals my F2 is what I'm looking for, and my A2 is 0.08 meters squared. Okay? All I do now is cross multiply. So this one would be 0.05 meters squared times F2, because I'm going to cross multiply these. Okay? Equals, let me use my calculator, 1,300 times 0.08. That would be 104 newtons meters squared. Okay, so I'm going to divide this so I can solve for F2. 0.0. And this is the same formula. Y'all have used this same formula, not the actual variables, but the same type of formula a couple of times now. So this is the same thing. So you cross those out. You're solving for F2. Okay, so you have 104 divided by 0.05. 104 divided by 0.05. Okay, so it'd be 2,080. Okay, my meter squared cancels, my meter squared cancels, so I'm solving for newtons. So that's my answer. Okay, it's fairly basic. You just got to make sure that you keep F1s, I mean your P1, F1, A1, the same piston. Okay. The only one that is going to, like, these are density problems, so you're going to have to use density on this, which is weight. Also, your density equals mass divided by volume, and you're going to have to use weight on this too to help you. So it's a kind of a two-problem thing. And this one right here is density also. My other book used it, and it's always good to review density. This is the best worded problem right here. So number 10 is the best worded problem. Make sure that when you're using pressure equals force over area, you're using pascals. And then when you, yeah, so I think that's it. Yeah. Okay, I think that's all. I think y'all can do the rest. Just do the best you can on the density ones. I have faith in you. Okay.